So for the solution, we are given the contingency table that we have filled up a while ago. Here is our degrees of freedom equal to 3. And then here is our level of significance 0.05. So they intersect at 7.815. So okay, this gives us the calculated chi-square value of 5.694444. In this video, we will be performing a chi-square goodness of fit test. The problem goes, as a student government representative, you are tasked with planning a school event. Your goal is to ensure that the food preferences of your classmates match the expected distribution that you have estimated based on previous events. You anticipate that 20% of students prefer pizza, 30% prefer burgers, 25% prefer sandwiches, and 25% prefer salads. You conducted a survey of 120 students and have the following results. 30 students preferred pizza, 25 preferred burgers, 35 preferred sandwiches, and 30 preferred salads. Perform a chi-square goodness of fit test to determine whether there is a significant difference between the expected and observed food preferences at a 5% level of significance. Solving this question using the ShinStats app, we open the app. Next, we click the main menu over here to open the list of calculators. Then we search for chi-square goodness of fit test calculator. Select this one. And then we will be presented with a contingency table, which we will fill up. So first, we fill in the different categories. In this case, we have pizza, we have burger, we have sandwiches, and salad. Next, we will be filling up the observed values. These are already given in the problem. 30 students who preferred pizza, 25 who preferred burgers, 35 who preferred sandwiches, and 30 who preferred salads. For the expected values, we are given the percentages. For the 20% of students who preferred pizza, so we multiply 20% or 0.20 by the total number of students, which is 120. That will give us 24. Under expected column, 24. Now next, we have 30%. 0.30 by 120. This gives us 36. Okay, next for sandwiches, we have 25%. So 0.25 times 120, we have 30. And lastly, for salad, which is also 25%, will also be 30 since they have the same percentage with the sandwiches. The next thing that we will do is to determine the level of significance, which is given in the problem as 5% or 0.05. Now that we have already filled up all the required values, we are now ready to press the button and perform the chi-square test. Here we will be prompted to watch an ad in exchange for a reward. So for the solution, we are given the contingency table that we have filled up a while ago. And then for step 1, we formulate the hypothesis. Okay, for the null hypothesis, the observed frequency distribution fits the expected distribution. And then for the alternative hypothesis, there is a significant difference between the observed and the expected distributions. Okay, for step 2, we now calculate the degrees of freedom. So in this case, using the contingency table, we use the following formula. df is equal to number of categories minus 1. So going back at the contingency table, we can observe that we have 4 categories. We have pizza, burger, sandwich, and salad. So there are 4 categories. So in this case, so 4 minus 1 will be equal to 3. Now for the step 3, we now need to determine the critical chi-square value. Actually, this is chi-square. So the critical chi-square value. To do this, we use a chi-square critical values table in the references below. So basically what we will do is locate the degrees of freedom in the first column. So as what we have calculated a while ago, the degrees of freedom is equal to 3. So this one. And then the next thing that we will do is to locate the level of significance alpha in this row over here. So the level of significance as what we have declared a while ago is 0.05, which is this one. Here is our degrees of freedom equal to 3. And then here is our level of significance 0.05. So they intersect at 7.815. So we have here our critical chi-square value equal to 7.815. So step 4 will be the decision rule. Okay, to formulate the decision rule, we will use the critical value approach, which means we compare the calculated chi-square statistic with the critical chi-square value. The chi-square goodness of fit test is actually a right tail test. That is why on this particular decision rule, we see the symbol is greater than. And when the test statistic is greater than the critical chi-square value, then we reject the null hypothesis. As a result, the decision rule is reject the null hypothesis if the chi-squared test statistic is greater than the critical chi-square value. Otherwise, we fail to reject the null hypothesis. The next for step 5, we have calculate the test statistic. So we have the formula here, summation of the observed values minus the expected values, quantity of that squared divided by the expected value. Basically, if we go back to the table, what happened was quantity of 30 minus 24, square of that divided by 24. The next 25 minus 36, okay, the square of that divided by 36. And then 35 minus 30, quantity of that then squared divided by 30. Then 30 minus 30, the quantity of that squared divided by expected value of 30. Okay, this gives us the calculated chi-square value of 5.694444. So step 6, formulate the conclusion. We now go back to our decision rule. Since the test statistic, this one, 5.694, is less than the critical chi-square value of 7.815, the result of the test is not statistically significant. Therefore, we fail to reject the null hypothesis stating that the observed frequency distribution fits the expected distribution. We have insufficient evidence to show that there is a significant difference between the observed and expected distributions. And optional, if the p-value of our calculated chi-square statistic is less than the significance level alpha, then we reject the null hypothesis. Otherwise, we fail to reject it. In this case, the right-tailed test p-value associated with a test statistic of 5.694, the p-value of this is 0.127460. Now, since this value is greater than the significance level alpha, the result of the test is not statistically significant. It's the same result whether we conduct a critical value approach or the p-value approach. That concludes this solution. If you have any questions with regards to this particular solution, particularly on performing a chi-square goodness of fit test, or if you have any suggestions or recommendations to make this calculator better, you may comment them down below. If you find this video helpful, please leave it a thumbs up, subscribe to this channel if you are not yet subscribed, and ring the notification bell so that you will be updated on our latest uploads. And as always, I'll see you on the next one.